We're going to go over the general form of sinusoidal functions or periodic functions. Here's the general form. We're going to go over a couple of examples. Sine and cosine. Take down this example and find the map of the function. Then sketch it. Sketched where it starts at the midline and then increases. Add the graph of cosine sketch where it starts at the maximum and then decreases. Max is 7, minimum is 1. I got that right because I had the midline is 4. I add 3 to get to 7, take away 3 to get 1, and the period stays at 2 pi for now. So let's keep going through this. The midline is y equal to 4, so that means I need to sketch the graph of y equal to 4. Done. And how is this shifted? We've got everything else down. Right, that shifts it to the left, right? By how much? By pi. So that means I've gone to the left by pi. And the last bit is, where does sine start? At its midline. So the very first point I put down is at its midline, which is at y equal to 4. After that, what does sine do? Look at my pen. My pen says that it goes to its maximum. So this next point has got to be its maximum, which is 7. After that, what does it do? It goes back to its midline. So my next point is going to be on the midline. And then the minimum is 1, midline, maximum, midline. And the completed graph looks just like that. Now I want you to think through that entire graph, internalize these two, internalize the process, and then start this very next graph. Find the map of that function. The only thing that makes it kind of tricky is the fractions, but nothing else is. Map of the function. Take a look at it. And now use the processes you did here to graph this. Think about what these mean, what this stuff means, and what the graph would end up looking like in terms of halves. So I have half, 1, 3 halves, 2, 5 halves, 3, to make it easier to graph. Look, don't do anything else until you've graphed it. Check your work. And then move on to the next example. We'll see is nearly the same as the first example, but there's a negative in front. So still do all of the work, find the map, and graph it, and check it when you're done. Look, when you've actually done it, then you're welcome to check your work. Here it is. What's the difference? Almost nothing. Almost nothing, except for it's flipped over. It's just like the first example, but it's flipped. And the reason is that sine of a negative, or sine of x rather, a negative sine x looks almost like this one, but instead of going up, it goes down, and then this way it goes up. So it's just flipped. So that means over here at pi, or in a negative pi, instead of going and increasing after the midline, I decrease, and that's the big difference.